All right, hey everybody. This is going to be a quick video on deriving the quadratic formula. So here it is. Here's the quadratic formula, by the way. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what we're going to derive, and the way that we derive it is by completing the square on a generic quadratic. So what's a generic quadratic look like? Well, it's of the form ax squared plus bx plus c equals 0. So this is just going to be like deriving the quadratic formula. If you need some help with completing the square or what those steps are, I just made another video just a few seconds ago, in fact, of how to do that. So you'll want to go check that out. So here I'm just going to run through the steps rather than like list them all out. And we're going to arrive at the quadratic formula. So the first step is that a, when it comes to completing the square, we need the coefficient on x squared to be 1. So since this is generic, a could be anything that is not 0. So a could be anything, so we want to generalize it and assume that a is not 1, so I'll first divide through by a. So step 1, this thing becomes x squared plus b over a x plus c over a equals 0. Okay. Okay, yeah. Then step 2 is I'm going to move the constant term, c over a, to the right-hand side. So subtracting that from each side, x squared plus b over a x equals negative c over a. All right. The next step is to add b over 2 squared to each side. And in particular, it's this term. So it's not just b itself, it's really the b in my new quadratic. So what I'll actually be adding to each side is plus b over 2a quantity squared is what we're adding to each side, because it's this thing, b over a divided by 2, which is b over 2a, square that and add it to each side. So on the left, I'll kind of write this as, I'll distribute the square, b squared over 4a squared, just for now. The left-hand side immediately factors, and this is the whole reason that we call it completing the square. I refer to it frequently as that this is sort of manufacturing a square, and I think that that is maybe, at least to me, it makes a little bit more sense, because that's what we're doing, is that we specifically add this term in so that the left-hand side becomes a perfect square. So we are manufacturing a square. And then on the right, let's see, I'll clean this up. I would need to multiply this piece by 4a on top and bottom, so the top would become negative 4ac. I'm going to write it as b squared minus 4ac. And then all of that is over 4a squared. So I just kind of did a couple of steps in there. You might want to convince yourself that this is true, that this is correct. Right. And now we're in a position, and this is kind of the beauty of completing the square, is that now we're in a position where we can just solve for x, like the way that we're kind of accustomed to solving for a variable. So I'll take the square root of both sides, and taking the square root of both sides, we have to remember to use the square root property. So this becomes plus or minus the square root of b squared minus 4ac over 4a squared. And then let's see, I'm going to do 2 steps in one on this next step. One, I'm going to subtract b over 2a from both sides, so move this over so that we have solved for x. I'm also going to simplify this 4a squared under here. When you have the square root of a fraction like this, you can sort of break it up as the square root of the top divided by the square root of the bottom. And the square root of the bottom, 4a squared, that's a perfect square. So this becomes x equals, and I'll write it this way, negative b over 2a. So I've subtracted this from each side, the negative b over 2a. X equals negative b over 2a plus or minus, and then here it becomes the square root of b squared minus 4ac. And the numerator, the denominator, is the square root of 4a squared, which is 2a. And now these have the matching denominators. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. which is the quadratic formula. So that's how you derive the quadratic formula. The beauty of the quadratic formula is that it's just completely plug and chug. One, it's completely plug and chug. Two, it solves every quadratic. So it doesn't matter if there are two real solutions, if there's one real solution or a repeated solution as they call it. It doesn't matter if there are two complex solutions. In either case, in any case, it will solve it, and you just plug things in. So you don't have to do any steps at all, just from whatever your ax squared plus bx plus c term is, plug it in. So I guess it wasn't really my intention to do an example, but it feels like I should do an example right now. So we'll just come up with some numbers. I'll try to keep them small and easy to work with. X squared, 3x squared minus 4x plus, I don't know, 2 equals 0. So, and I'm just making sure this doesn't factor, because if it factors, then if you can factor a quadratic, it's usually faster and easier to just factor. So 6, two numbers that multiply to make 6 and add to make -4. No, that's not a thing. If it was a -6, that would be a thing. But no, two numbers that multiply to make, no. Okay, so yeah, and we can just plug things in. So a is 3, b is -4, c is 2. So x must be -b, so +4 plus or minus the square root of 16 minus 4 times a times c all over 2a. So 4 plus or minus, let's see, what are we getting here? Am I going to give myself complex solutions? It looks like it. 12 times 2 is 24. Yeah. 16 minus 24 is -8. All over 6. Let's see, so -8, we can pull out the I, and the square root of 8 factors down to 2 root 2. So this is going to be 4 plus or minus 2 root 2i over 6. This is kind of the more standard form of writing this, by the way, with the I after all of the real parts. It feels strange to me. I kind of prefer, frankly, to write this as 2i root 2. But yeah, I guess that's actually sort of not standard. And then these all share a factor. 4, 2, and 6 all share a factor of 2. So this becomes 2 plus or minus root 2i over 3. There, we solved it. Just that fast. So yeah, quadratic formula, very powerful, very fast, very efficient. If you have any questions, let me know. I'll be happy to answer them.